bring it in. All right. Last week and going into exam 2, we've been on statistics. So much statistics. Okay. On Friday, we started talking about things like the mean, median, mode, right? All of these values that correlate with the center of your data that you gathered from a statistical study. Ringing any bells? I know we have the whole weekend, but hopefully some of this is still familiar to you. Now, today, we're getting even more specific about what we're talking about with data. When your data behaves a certain way, meaning all of these values that you get line up within a particular pattern, we're going to call that the normal distribution. I haven't told you what pattern is yet. Okay? Basically, what's going on is when you measure all of your observations, right, and you graph everything, you get this lovely picture like this, a bell curve. Okay? We saw an example of this in the notes, right? This is a unimodal curve, right? Because there's only one hump, just one, not two, just one. All right? When your data lines up nicely like this within what we call the normal distribution, there are particular properties that you can study. That's what today is about. Okay? I would like to get all the way through homework 12, so hang with me. Okay? It is going to be a little bit technical. You do have this picture in your notes, but I'm leaving it on the board for reference for a couple of examples that we're going to go through today. Okay? Let's have those calculators because we will need them a little bit, not too extensively, but a little bit. And if you have already submitted your attendance, go ahead and put your business away. The only technology you should really need is your calculator. We're done with that. Okay. Here we go. All right. So, the normal distribution, as you can see according to the picture, this is a symmetric, bell-shaped distribution of data. It has one book, like we said, so again, it is unimodal, one. This high point, as you can notice here, corresponds to the mean, x bar. That's what we talked about on Friday. Okay, so we're tying this all in. Okay, that's stuff I just told you. Now, the probability of any interval of outcomes is the area under the curve. Okay? So, say you have all of your data values, right? Every single value that you observe from your statistical study shows up somewhere under here. Okay? And then these percentages tell you that, 68% of your values are going to be within this range. 95% of your data values will be between this range, that far away from the mean. Remember we talked about the standard deviation, right? That's what these bars pertain to. Here's your mean. Each bar is one standard deviation away from the mean. Okay? That's why we've got sigma, 2 sigma, 3 sigma. Okay? Now, of course, the other thing is, since all of your data is under the curve, if you take all of this underneath it, you have the full 100%. Right? So that's all your data. Now, conditions. How do you know you've got a normal distribution? Well, it has to follow these four characteristics. Most of your data values have to be clustered near the mean. Right? According to this, 68% of your data is one standard deviation away in either direction from the mean, right? Most of your values are here. All right? Then you also have to have them spread evenly around the mean, so it has to be symmetric, right? If it spreads out evenly on either direction, you should get a nice symmetric curve. We talked about that on Friday as well. Larger deviations from the mean are very rare, meaning you should not have very many outliers, if any at all. Those are the values that are like way, way out here, way far away from the mean. Very few and far between. copy of the picture that I drew up here. Right? For the mean, we use the notation X bar on Friday, so I'm just bringing that back, something a little bit familiar. And to denote standard deviation when we're talking about a normal distribution, we're going to use this symbol right here, sigma. Okay? Little baby sigma. If you're Greek, you know the big sigma, this is the baby sigma. Now, here's where those percentages come from. 68, 95, 99.7. 68% of the observations fall within one standard deviation of the mean, meaning this. Okay, here's a pretty picture. Remember, the middle line stands for your mean. In either direction, so one standard deviation to the left of the mean, one standard deviation to the right of the mean. Within those two values is where 68% of your data should show up. Okay? Then add another standard deviation to the left, one more to the right. You are now two standard deviations away from the mean in either direction. That's where 95% of your data shows up. Right? 95% of your results are going to be between those two numbers. And then go one more, 3 standard deviations to the left, 3 standard deviations to the right. That's where you got 99.7% of your data value. Okay? That's all that means. Now, let's look at an example. So, the resting heart rates for a sample of individuals are normally distributed with a mean of 70 beats per minute. Standard deviation of 15. Find the percentage of heart rates that correspond with the following. Okay. So, let's tie this in with our pretty picture. We said that the mean is 70. Okay, so this is going to be 70 beats per minute right here. Right? Line down the middle is 70. Now, the standard deviation is 15. That means each of these sigmas, right? So this is plus 15. If you go 2 sigmas or 2 standard deviations away, that's 2 times 15, right? So if we add 15, we're going to the right, you get 85 beats per minute, and you get 100 beats per minute, 115 beats per minute, right? We're just adding 15 because that's each standard deviation. Relatively painless so far. Do the same thing going to the left. Instead of adding 15, we have to subtract, right? Because the number's going to get smaller. So that gives us, let's see, I wrote this out a little faster. 70 minus 15 gives us 5. Take away another 15, 40, and then another 15, 25. Okay? So we haven't even started talking about solving the problem yet. We're just setting up a pretty picture to help us figure it out. All right. Now, find the percentage of heart rates that are less than 70. Okay, this one you don't really have to think too hard about. 70 was the mean, right? So it's directly in the middle. It splits the graph in half. Keyword there, in half. So, if this is the halfway point, how many of your values are going to be less than 70? that 2 standard deviations in both directions is 95%. If we only want this piece right here, you take your 95% and divide by 2. That's it. Gives us a grand total of 47.5%. How are we doing so far with reading this normal distribution? That last problem? Sure. Okay. We are looking at the values between 70 and 100, right? Okay, between 70 and 100. So this is 2 standard deviations in one direction, right? Well, according to our graph, we don't have 2 standard deviations in one direction, we have it in both, right? That's the 95%. But we don't care about this side of 70, we only want this piece right here. Well, this piece is exactly half of the entire 95%, all right? That's why we just do 95% divided by 2. Okay? There's one example. I think we got a couple more. Yep. Okay? Same idea. Resting heart rates. Still with a mean of 70, still a standard deviation of 15. Find percentage of heart rates between 55 and 100. Okay. Well, 55 is 1 standard deviation to the left, but 100 is 2 standard deviations to the right. So we got to use our trick that we did for part C, and we got to kind of combine it a little bit. So, starting at 70, right, we go 1 standard deviation to the left. Now again, our graph doesn't give us 1 standard deviation to the left. It gives us 1 in each direction. Okay? So that means we're here, right? But I don't need both sides of it. I need this chunk first. So what percentage is right here? 34%, right? We need that piece, and then we can go 2 this way. So the first piece, 1 standard deviation to the left, we've got 34%. Now, going in the other direction, we just saw this in the previous one. We're going to 100, 2 standard deviations to the right. Okay, so how much was right here? 47.5. That's the one that we found in the last one. So, the 34% from the 1 standard deviation to the left, plus the 47.5, the 2 standard deviations to the right. That goes from 55 to 100. Put it together, you get, I have, where's the numbers? 81.5%. 45 is one standard deviation away, right? That means we need all of this stuff right here. Right? We need the far left graph. Right? It doesn't start at the mean, though. And here's where we gotta work backwards. If we know from the mean all the way to the tail end is the full 50%, right? So we mean out, that's 50%. We can cut away a chunk of it that we don't need. From here to here, right? Cut away this chunk right there, which leaves you with this piece. See what I'm saying? You take the whole 50%, cut away this one interval you don't need, that leaves you with 55 and below. Still with me? So if we write this out, we know we have a full 50%. We'll do this in another color so you can distinguish that. Okay. Minus. Now I need to know how much this piece is right here. Right? That's the chunk that we're going to cut out. How much is here? 34%. So we take the whole 50, cut away the 34% that we don't need, gives us a grand total of, I've got 16%. So 16% of your heart rate is going to be less than 55 beats per minute. Some yogis can meditate and get his heart rate down to like 32. Okay. Now we got to go the other direction. Do the other tail end. We want the heart rates that are more than 100. Okay. Same idea. But we're going the other direction. So, from your mean all the way to the right is another 50%. Yes? Okay. This is 50% of your graph. Well, 100 cuts off here. We want this guy. The parts that are more than 100. Right? We want all of this. So, take your 50% and cut away the chunks you don't need. Pieces you don't need are this value right here, which will leave you with just 100 or more. Still with me? Okay. So we're looking at the left side of the graph. 50%. Okay? 50% is the whole thing. And we're cutting away 2 sigma, right? Cut away these 2 sigma. Well, look at your percentage. That pertains to the whole 95%, but we only want half. So we're cutting away 47.5. Yes? I got 2.5% left over. When in doubt, draw the graph. Shade in what you're looking for. Okay? Questions so far?
Can you go back to the last screen?
Which one?
Back to the last screen so I can verify my
Last screen?
answers.
Sure.
There, thank you.
Gotta say when.
Thank you.
All right. Now, another one, same idea. Resting heart rates for a sample of individuals normally distributed. Keywords there, normally distributed. So you know you're working with this pretty picture. Okay. We have a mean of 70. So our number right down the middle is 70. And a standard deviation of 15. Between what two values do 99.7% of heart rates last? Okay, so now we're going backwards. Instead of finding the percentage of heart rates between certain values, we're going to say, well, what are the heart rates in this percentage? Okay. Between what two heart rates do 99.7% minute. On the other end, plus 3 sigma goes with 115 beats per minute. So, 99.7% of your heart rates are between 25 beats per minute and 150. Again, when in doubt, draw the pretty picture for yourself. Or copy that down on the paper if you want. That's why I drew it up on the board so you can have it for reference. So when you're doing your homework or taking your quiz, read the wording very carefully. Sometimes it's going to ask you for the percentage between two values, or more than a value, or less than a value. Or on the flip side, it'll ask you what percentage is between what values is your percentage. Okay. All right. Change things up a bit now. Life isn't always pretty. Let's have you copy that impossible question first. We're at Kroger, good old Krogy, and the number of months that clerks work there is normally distributed with a mean of 5 months. Okay, normally distributed, so you know you can draw a pretty picture, draw a bell curve, line down the middle. 5 months. Standard deviation of 1.5 months at a time. Between what two numbers of months do 95% of the clerks go to work? So, when you set up a picture, put your mean down the middle, set up your standard deviations. You're going 1.5 in each direction, right? And then we want to know where 95% is. Okay? So that's 2 sigma away. Look at your corresponding values for 2 sigma when you work that out. Still see pencil keys. Give me a second. All right. So quick summary. We're not done yet, but I want to give us a little rundown before we add some new stuff into this. We do a statistical study. You collect a bunch of data, right? All your observations from your statistical study. Then, if your data has particular characteristics, when you graph it out, you get this pretty picture, this bell curve. Okay? Unimodal, there's only one mode, right? And using the stuff that we did on Friday, you can find your mean, mode, median, and standard deviation. That's the big thing, standard deviation. When you set up your graph, the mean, or x bar, goes down the middle, and in either direction, you go. 1 standard deviation, 2 standard deviations, 3 standard deviations, go both ways. Within these groups of standard deviations, you have a certain percentage of your data. Right? 68, 95, 99.7. That's the rule. Always and forever. That will never change. And then you can work some problems and figure percentages out, so on and so forth. Now coming up next, everyone done writing? Getting there? The next thing is, all of the examples we've done so far, everything worked out really, really pretty. Right? Everything was exactly 1 or 2 or 3 standard deviations away from the mean. However, life isn't always pretty, right? Numbers get very ugly very fast. What happens if you're trying to analyze your data and it's not within an exact standard deviation? We got to do something else if that's the case. So if the values you're looking for aren't pretty, they don't correspond to an exact standard deviation, we have to use what's called the Z-score. Okay? And a standard normal table. So if you flip through your notes at the beginning of the semester, you'll notice at the very beginning of your notes in front, there should be a table. correct set of numbers. Should be right at the very beginning. That correlates to normal distribution. You will get to use this on the test. The easy one. You can write the new one. Alright? So here's the example. Here's what we're talking about. Going back to the example we were just using. Statistical study with heart rates. They had a mean of 70, standard deviation of 15. But say you wanted to find out the percentage of heart rates that were lower than 72%. But our standard deviation was 15. 72 does not correlate with a standard deviation of 15, right? If this is 70 beats per minute, 72 is somewhere in here. That's not going to be a pretty number. So we can't use our regular 68, 95, 99.7. Instead, we use the z-score. Here's how you find it. Okay. Another term for the z-score is the standard score. We like saying z-score. Okay. There's too many standard things in our vocabulary, so we use z-score. To find the z-score, you take whatever data value you're looking at. From that value, subtract the mean. It should look familiar. It's just like what we did for each of our values when we did standard deviation. And then you have to divide all of that by the standard deviation. Now, when you do your z-score, you do have to worry about positive and negative values. Okay? It does mean something. Make a note to yourself if you need to. With your z-score, positives and negatives make a difference. Pay attention to those. Okay. All right. Here's an example of what we're talking about. We have a mean of 21 with a standard deviation of 4.7. Find the z-score for 30. Okay, well, rework our numbers. If you have a standard deviation of 4.7, you're not going to get to a solid 30 from 21, right? You can't add 4.7 and then another 4.7 and get 30. So, go to the z-score. Our data value that we're looking for is a 30, all right? 30 minus the mean of 21, okay, goes across the top, and it tells you the standard deviation is 4.7. So divide by 4.7, you get 1.91. That's the z. Z is 1.91. Okay, so that means if you have a test score of 30, you are 1.91 standard deviations away from the mean. Since it's a positive 1.91, you are to the right of the mean. You're above average. Doing good. Okay. A little bit more technicality stuff. The nth percentile data set is the smallest value in the set with the property that n% of the data are less than or equal to it, meaning we are not doing inside out anymore. We're talking about z-scores. We're talking about the value, everything to the left. The value and everything to the left. Right? Z-score gets a little bit more turned around. So we're baby steps today. Baby steps. A data value that lies between two percentiles is said to lie in the lower percentile. Okay, lower. This should be the table in your notes. And you do have one right where we are in the lecture. There should be another version of this at the beginning of your notes. Now again, as I said, with my little warning, the table gives the percent to the left of the score. When you're doing z-score, you're not going from the inside out anymore. That only works when we've got the 68, 95, 99%, 99.7%. Okay? Z-score, take your value, look at everything to the left. Take your value, look at everything to the left. Okay? it in. So we've got a nice pretty bell curve, right? From our data, we find out there's a mean of 67, a standard deviation of 8. Okay? About what percent of the scores were below 85? Okay? So 67, let's see, 67 plus 8 gives us 75. 75 plus another 8 does not give us that value of 85, right? So we're not able to work with our nice, pretty standard deviations and the pretty percentage thing. So we have to go to the z-score. All right. $85 is not a pretty number for this study. So, first thing you have to do is the z-score. To calculate the z-score, you take the value that you're looking at. So we're looking at, well, let's have to write our formula. You take x minus x bar and then divide it by sigma. Sigma is our standard deviation. X bar is still our average. X is the data value that we're looking at. So, plug it in. We're looking at a score of 85. And we have to subtract away from that our mean of 67. And then we divide by our standard deviation of 8. Punch that in your handy calculator. I got approximately 2.3. Now that's not 2.3%. Not 2.3%. That is your z-score. In order to find out the actual percentage, go to your table. Okay? You've got columns of z-scores and percentages that alternate. Okay? Z-scores and percentages. Find your z-score of 2.3. Okay? So make sure it's a positive 2.3. Should be somewhere over here to the right of your page. Okay? Find your z-score of 2.3. From there, look over across the way at the percentage that goes with the z-score of 2.3. I've got a percentage of 98.93. So, let's find the z-score. Use the table. So z equals 2.3. That goes with, what did I say, 98.93? Okay. About what percent of scores were below 85? 98.93% of your scores were below 85. Okay. Now again, before we go to this next example, yes, it's a normal distribution, but when we do z-score, we're looking at the value and everything to the left. It works out what percent were below 85. That means 85 is somewhere, let's see, what was our mean? 67. So 85 is somewhere in here, and we're looking at all the stuff that way, right? Here's the difference with part B. What percent of the scores were above 65? We got to work backwards again. Z-score gives us everything that way. We're looking for answers in the other direction. So if you see the keyword above or more than, that's when we're working backwards. Alright. So let's use some intuition here. We want something above 65. We'll say 65 is, let me see, 67 was the mean, so 65 is somewhere over here. Right? We want all of this stuff on the right side of 65. So what we can do instead, everything under here is 100%, right? And again, you can cut away the chunk you don't need. So if this is 65, you can cut away everything to the left of it. And that leaves you the percentage to the right, yes? So, we got to add an extra step. Still got to find the z-score. my data value, minus the mean of 67, divided by our standard deviation of 8. If you plug that into your calculator, you should get a negative 0.25. Right? Okay. Remember, positives and negatives make a difference with the z-score. So, go to your handy-dandy table. Find a z-score of negative 0.25. That's going to be, I've got it in the second column. Okay? Negative 0.25 correlates with a percentage of 40.13. Right? But, hold on a second. Remember what I said. That means there is 40.13% to the left. That's less than 65. I want the values that are more than, go the other direction. So I have to take the whole 100% and cut away the piece we don't need. The piece we don't need is 40.13%. We're going to cut away that chunk over there. So step 3, take your 100%. Minus the piece you don't need, 40.13. And that leaves you with a grand total of 59.87. Hang with me, some of y'all are getting fidgety. We got a little bit more to go. Don't you worry. Questions on the z-score before we move on? Got a question in the back? Maybe? Why did I subtract from 100? Okay. Remember, the z-score includes values to the left side of the value that you're looking at, right? We're looking at a value of 65, but look at what the question's asking. I don't want the values below 65. I want the values above 65. Just take your whole 100%. Your z-score gives you all of this stuff, right? That's stuff you don't want. We want the other end of it. So you cut away the 65, leaves you with that percentage. So that's the 100 minus 40.13. Kind of, sort of. Got to visualize. Draw pictures if you need to. Okay? Other questions? When your numbers turn out pretty, you can use the 68, 95, 99.7 distribution. Right? You go from the inside out. When the numbers are pretty. When the numbers aren't pretty and do not correlate with a value of the standard deviation, you use the z-score. The z-score gives you a value, and it gives you the percentage to the left. Always and forever. Z-score gives you the percentage to the left side of that value. So sometimes, if you want more than or above a certain value, they'll work backwards. Subtract from 100. Now, statistical inference. We do not necessarily live in a perfect world. And sorry, my symbols got a little screwed. So that means something could go a little bit wrong. Someone could have lied on a survey, right? You could have some freak anomaly in your petri dish. Some little speck of dirt that just ruins part of the experiment. So your data values can be skewed. Skewed? Okay? That's what this next bit is about. We're going to at least start it so you can get started on the homework. Now, question, what's the percentage of Americans who approve of the way the president is handling his office? Well, if you're going to do a true measurement, you'd have to talk to every single person in the country. We don't have time for that. Okay? So the true proportion would be the actual amount of people who say yes divided by everyone in America. Again, we don't have time for that. So instead, you can do a statistical study, take a sample of your population. See, we're tying it all back in together. Take a sample, and then within that sample, figure out who thinks he's doing well. And then divide that by the total amount of people in your sample. That's what we call the sample proportion. Notation. Sorry, this is kind of screwy. It's supposed to be P for the true proportion and P hat or the sample proportions. I don't know where they come up with this stuff. I'm just doing it on home. Okay, so P hat, the little caret on top, that's P hat when we're talking about your sample. So, suppose you conduct a telephone poll of 1,250 people, and you ask them whether or not they favor mandatory sentencing for drug-related crimes. Out of this 1,250 people, you've got 580 who say yes. What is the sample proportion of people in favor? Okay, sample proportion. You just look at your sample. How many are in favor? 580. Out of how many total? 1,250. Put that into your handy dandy calculator. Let's see, I got 0.464. Correlates to 46.4%. Okay. One more, and then there's a couple more slides. Actually, you know what? Here's your possible exam question. Let's end it on that. And of course, pink pad of paper.